Hello friends, today lecture is on DevOps certificate training with generative AI. Today topics is IaC concept and benefits. IaC means infrastructure as code. Infrastructure as code concept and benefits. AWS CloudFormation fundamentals, Terraform basics, Terraform configuration files, Terraform concepts, SCL, providers, state management. Next topic is the Terraform commands. Next, the Terraform states commands, modules, variables, and outputs. Next is the security in infrastructure as code, secrets management, and policy enforcement. Testing infrastructure code, AI assistant code generation, enemy detection in infrastructure metrics, resource post prediction, and automation using machine learning model. So today is this topics. Learning objectives. This is the learning objectives. First topic is the infrastructure as code. IaC. Short form is the IaC. Overview of infrastructure as code. Infrastructure as code is a DevOps methodology that uses version descriptive model to consistently define and deploy infrastructure. Core infrastructure elements are network, virtual machine, load balancer, and storage. This infrastructure is code of elements. Benefits of infrastructure as code. Number first is the automation. Save time by automating repetitive tasks. Automation क्या होता है हमारा टाइम की बचत होती है to save time is automated. Number second, scalability. Quickly adapts to demand. Third is the version control. Tracks infrastructure changes by Git. Git के थ्रू हम infrastructure कोड को चेंज कर सकते हैं. Consistency, avoid configuration drift by ensuring the same setup. So this benefits of infrastructure as code. Challenges without infrastructure as code. Configuration drift. First is the configuration drift. Second challenge is a manual error during setup. Third is a inefficiency in scaling environments. Fourth is a lack of version control. So these challenges of infrastructure as code. Of infrastructure as code tools. These tools are used in infrastructure as code. Terraform used to infrastructure code, cheap, Ansible, Puppet, and Lumin. So these tools are used in infrastructure as code. Type of types of infrastructure as code tools. टूल्स हमारे इंफ्रास्ट्रक्चर कोड कितने टाइप्स के होते हैं. नंबर फर्स्ट, कॉन्फ़िगरेशन मैनेजमेंट टूल्स. कॉन्फ़िगरेशन एंड मैनेजमेंट टूल्स मैनेज एंड ऑटोमेट सॉफ्टवेयर इंस्टॉलेशन, कॉन्फ़िगरेशन एंड अपडेट ऑन सर्वर. Any update, installation, and configuration and updates on server. These tools are used in infrastructure as code. These tools are named Ansible. Tools are named Ansible. This is the Puppet. This is the chip. So these tools are used configuration management tools. And second is the server templating tools. Server templating tools create reusable server templates to define infrastructure in a declarative manner. So this is the code commit tools, AWS code commit tools. This is the cloud formation. So these tools are you server templating tools. And next is the provisioning tools. Automate the creation and management of infrastructure resources. So these tools are you provisioning tool. This is the tool's name is Terraform and Lumen. So these tools are you provisioning tools. So types of IaC tools is the three types of IaC infrastructure export tool, configuration management tool, server templating tools, and provisioning tools. So these tools are used in infrastructure export tools, Ansible, Puppet, and G, in uh, AWS Cloud Commit, and CloudFormation, Terraform, and Plume. So these tools are used in infrastructure export tools. Next topic, next topic is infrastructure export in DevOps. Infrastructure as code automates the provisioning and management of infrastructure using code, making it an integral part of modern DevOps practice. So infrastructure as code in your DevOps. So write a code is a developer is a write a code and infrastructure code. Infrastructure uh, code is a scripts, templates, and policy. So this is a infrastructure as code, and this is a version control tools. So and push to command, push to script and templates to infrastructure as tools, Terraform, Ansible, Puppet, and Chi, and infrastructure is ready. So this methodology is infrastructure code in DevOps. Next topic is AWS Cloud Formation. AWS Cloud Formation. What is AWS Cloud Formation? A service that enables you to model, provision, and manage AWS resource using infrastructure as code. This infrastructure code, AWS Cloud Formation tools name. Cloud Formation. This is a cloud formation, and this is a EC2 tools, SNS tools, code pipeline, VPC, S3, RDS, and API gateway. So this is AWS Cloud Formation tools. Each This tools is connected to JSON file and YAML file. AWS only two files is connect, JSON files and YAML file. So it enables you to define your infrastructure in code using infrastructure is code using on JSON and YAML templates. Only two types of templates are using AWS Cloud Formation: JSON template and YAML template. Feature of AWS Cloud Formation. Cloud Formation feature is this is a feature in AWS Cloud Formation. Infrastructure as code is change sets, cross vision account management, drift detection, and resource management. This feature of AWS Cloud Formation. Working of AWS Cloud Formation. Working of AWS Cloud Formation. Number start is AWS Cloud Formation is code your infrastructure. Write a code in JSON and YAML file. So from scratch using the Cloud Formation template language in their YML language, template और JSON format. YML format और JSON format में हमारी लैंग्वेज डॉक्यूमेंटेशन टेम्पलेट की लैंग्वेज होनी चाहिए. So start with one of the many available sample templates. Next is check your template. Code locally or upload it to S3 bucket. Code this template is ready to upload the S3 bucket. So to check your template is okay or any error. And next is use AWS CloudFormation. Through the browser console command line tools API to create a stick based on your template code. Next is AWS CloudFormation provision and configures the step and resources you specify in your template. So this working of AWS CloudFormation. Number first is code your infrastructure. Number second step is check your template. Number third is use AWS CloudFormation. Number next is step is AWS CloudFormation. So this working of AWS CloudFormation. Next topic is CloudFormation templates. Template is JSON and YML file that defines the AWS resources and configuration needed to provisioning and manage infrastructure. JSON file and YML. This template acts and blueprints to automate the consistent creation, updating, and deletion on AWS resources. AWS resources create, update, and delete. So these template automate consists of creation, updating, and deletion in AWS resources. So cloud formation template only JSON and YML template. Next lecture is JSON, difference between JSON and YML template. So I am next lecture is JSON YML. Okay. So next topic is cloud formation template. What? This is a JSON template, or this is format is a YML template. YML template is a simple format, and JSON template is a string format. Okay. So this is a body start and close body start and close. This is a simple format, no body, only version date. This is description string, metadata template, metadata parameter, set of parameter, rules, set of rules, mapping, set of mapping, condition, set of condition, terraform, transform, set of transform, resource, set of resource, and output, set of output. This is a line wise and simple language. Okay. So this is a YML language, YM template. This is a JSON, string wise. String wise, say metadata, template of metadata, body close, parameter, body open, set of parameter, body close, rule, set of rules. So this is a string types. Okay. So this difference between YML and JSON file. JSON file is a simple format and JSON, sorry, JSON file is a string format and YML is a simple format. So this difference is a template of cloud function, JSON and YML. Okay. Advantages of cloud formation templates. Advantage क्या है हमारा cloud formation templates? Automation and consistency, infrastructure as code IaC, usable and scalability, cost management, rollback and recovery, centralized management. Okay. So this difference of JSON and YML format. JSON full form JavaScript Object Notation, YML, YML, IN Markup Language, GEO for human less. This is notification. JSON is a string format, so notification. YML is a simple format, so more easy. GEO machine, machine के लिए JSON and YML both use are easy. Syntax, this is strict. सिंटेक्स में जेसन फाइल हम स्ट्रिक्ट सैंपल में कम करते हैं एंड YML इज फ्लेक्सिबल. कमेंट्स अलाउ, जेसन में नो कमेंट. जैसे हम डबल स्लैश में कमेंट लिख देते हैं तो जेसन नॉट यूज इन कमेंट्स अलाउ. YML इज कमेंट अलाउ आर यूज डबल स्लैश any question to commit double slash and question. File extension .json, this file extension .yaml या .yml तो फाइल में एक्सटेंस कर सकते हो. YAML लिख सकते हैं या YML. So this is the JSON and YML difference. JSON और YML में दोनों में क्या डिफरेंस होता है? JSON is a string format, YML is a simple format. String is name, body start, name, Rahul age 25, double comma, skill AWS Python Docker, and YML example name Rahul age 25, skills AWS Python Docker. So this format is YML, this format is JSON. Rules must use this bracket and rules use indentation instead of brackets. Key must be in queues. Must be queues command required. Queues command required. This queues command required very strict formatting. And no queues needed is a YML height. Looks cleaner and more readable. Okay. Readability server host local host p port 8080. This readability server, this server name host local host port 8080. YML was designed to be easy for human. YML design human से simple and easy बनाया गया. Command support JSON no comments. कमेंट सपोर्ट में JSON नो कमेंट्स, जैसे कमेंट नो कमेंट सपोर्ट. सो दिस इज अ फॉर्मेट ऑफ JSON फाइल. कमेंट सपोर्ट YML कमेंट सपोर्ट कमेंट्स. ये हैज यूजर इन्फॉर्मेशन हैज या डबल स्लैश, सो यूजर इन्फॉर्मेशन नेम राहुल. सो दिस इज अ कमेंट सपोर्ट. JSON strict favor parsing errors. YML is flexible, easy written, but indentation mistakes can break it. अगर हम कोई मिस्टेक हो गई तो हम प्रोग्राम ब्रेक हो जाएगा. JSON is used API, web apps, data exchange, JavaScript apps, and YML tools are used. DevOps tool, configuration tools, configuration file, Docker, Kubernetes, CloudFormation template. So this is used in YML, and JSON is API, web app, data exchange, and JavaScript apps. Okay. JSON is a machine friendly. JSON क्या है? मशीन फ्रेंडली. YML इज ह्यूमन फ्रेंडली. JSON फाइल हमको बनाना है तो किसी ऑटोमेशन के थ्रू बनाएंगे. सो नॉन मिस्टेक एंड YML इज ह्यूमन फ्रेंडली. हम खुद ही बना सकते हैं स्टेप बाय स्टेप. So this difference is JSON and YML file. This advantage of CloudFormation template, automation of and consistency, infrastructure as code, usability and scalability, cost management, rollback and recovery, centralized automation. So this is the advantages of CloudFormation templates. Terraform. Terraform is a open source infrastructure as code tools. Why SQL? Terraform एक open source infrastructure as code tools है and tracks sources based state files, automates infrastructure lifecycle, works across multiple cloud formation, use a declarative language used for infrastructure provisioning. So this is a Terraform workflow. First is a write a code, plan, this code and apply the code in the server. So Terraform workflow. Terraform workflow is a three-step: write, plan, and apply. Write a code, plan, and apply. It is three-step of Terraform workflow. Terraform workflow. Write. Write is a review solution against acceptance criteria. Write Terraform configuration in code editor. So this is a write a code. Plan generates an execution plan, outlines action to create, update, or destroy infrastructure. Next is apply, executes the plan after approval, ensures proper order and respects resource dependency. So this Terraform workflow of a write, plan, and apply. Features of Terraform. Features of Terraform. One first features is infrastructure as code. It enables users to define infrastructure using high-level configuration syntax. The second is the execution plan. It previews the changes your configuration will implement. Resource graph. Terraform creates dependency graph for parallel resources creation. Exchange automation. Execution plans and resource graphs helps user anticipate changes. To these features of Terraform, IaC, execution plan, resource graph, and change automation are the Terraform feature. Tools integrating with Terraform. Terraform tools are used for integration tools. CI/CD tools, continuous integration, and continuous deployment tools. Number second tools used in cloud providers, AWS and Azure. Cloud provider, Imagine Web Service and Azure. Monitoring tool is a Datadog and image management is a Packer. These tools are used in integration Terraform tools. Terraform architecture. Terraform architecture enable efficient infrastructure management and provisioning across cloud for platforms using a declarative approach. Terraform plan, Terraform apply. Engineer write a code in a Terraform plan and Terraform apply. This is a .terraform file, tf.tf files, Terraform manifest file. This is a Terraform manifest file. Write a code engineer and Terraform manifest file.tf file and Terraform code. This is a Terraform code and state file.tf state. And next is a providers tools are used. Azure integration tools are used. Azure, AWS, and VMware provisioning, remote execution, local execution, and plugin support. So, plugin support is the Jenkins tools. And next is the Azure AWS cloud service providers. Cloud service providers are Azure and AWS. So, this Terraform architecture. Terraform configuration files organized into modules for usability. Terraform configuration file .tf file write in SCL for simplicity. Written in SCL for simplicity. SCL is a HashiCorp configuration language. Component of Terraform configuration file. Providers, resource, variables, and output. These components of Terraform configuration files. State management in Terraform. The purpose of state management in Terraform is to make configuration to real world resources, track resource change over time, supports remote state storage for team collaboration, ensures consistency in infrastructure management. So this management in track resource, support remote state, and ensure consistency. Terraform configuration syntax SCL. SCL is a HashiCorp. SCL from a HashiCorp configuration language. It's a declarative language. And SCL is a declarative language used to define infrastructure resources. SCL SCL को हम declarative language भी बोलते हैं. So HashiCorp configuration language is a declarative language. Key syntax element block represents a distinct unit of configuration. Argument key value pair that configure setting through block, expression, range variable, or other dynamic value. This is the program of SCL and .tf file. Source AWS VPC main body open CIDR block variable.base CIDR block body flow. Block type, this is block type, the different syntax and body flow arguments. So this is a configuration syntax. Terraform configuration syntax. Okay. Configuration structure. Configuration structure. Provider block defines the cloud provider and any configuration of provider. Provider AWS region US best to US hyphen best hyphen 2 and US hyphen east hyphen 2. This is the two zone of provider. Okay. Resource resource block define the actual infrastructure resource that Terraform will manage. Resource infrastructure extends example AMI. This is a AMI and AMI code. Instance type T2.micro and body clock. So output block define the output of the configuration after applying it. Output instant IP value in protect imagine with service AWS instance dot example public IP body flow. And variable block allow dynamic configuration of resources providing flexibility. Variable instance type default T2.micro body flow. So this configuration of the structure in Terraform is a code. Providers in Terraform. Providers are plugins that allow Terraform to interact by API server. Terraform is a support and plugin support. Declarative of provider in Terraform. This is a Terraform as a code. A provider define resources and data sources available or specified service. For example, first example is the AWS provider allow you to manage AWS sources like EC2, Elastic. EC2 is a Elastic Cloud Compute. S3 and Spectra. The Azure RM provider manage Azure resources The Kubernetes provider lets you manage Kubernetes cluster. S3 is a simple storage service. S3 simple storage service. S3 platform is a simple storage service, and EC2 is a elastic cloud compute. So this is the source of AWS management resource. Terraform commands. Terraform commands are used in multiple commands. Init. The init command is used to prepare the working directory for follow-up command. Syntax Terraform init. Validate. Validates the configuration file to ensure they are syntactically correct. Syntax Terraform validated. Plan. So a plan of Terraform changes, create, update, or destroy resources without applying them. Syntax Terraform plan. The syntax I use Terraform. Terraform command apply executes the changes from the plan to update or provision infrastructure. Syntax ru Terraform apply destroy destroy all resources defined in the Terraform configuration file. Syntax ru Terraform destroy. So display detailed information about the current state of resources managed by Terraform. So Terraform so command is used Terraform so. If these commands are used Terraform. And output, final output, to check command output are useful for displaying important information after infrastructure is created. Terraform out. FMT automatically format draft Terraform configuration file .tf file to ensure they are consistently styled. Terraform FMT. This command is used Terraform FMT. Terraform resources. Terraform resources. Terraform resources are the fundamental building block in a Terraform configuration that represents and manage infrastructure component. These resources define a desired state of different architecture elements such as virtual machine, database, and network security group. So this is the Terraform sources. Terraform sources is a virtual machine, database, and network security group. Terraform resources syntax, resource type, and resource name. So three resource syntax. Resource type, and resource name. Configuration setting for the resource. Attribute 1 equal to value 1. Attribute 2 equal to value 2. So can be hard-coded derived from variables or computed using interpolation. Example, AMI hyphen 0ABE125 colon T2 dot micro. So this Terraform resource syntax. Terraform state commands. The command used for managing and inspecting the state file that Terraform used to track and resource it manages. These commands help manage infrastructure state, ensuring consistency between configuration and deployed resources. So this Terraform state command. Terraform modules. Terraform modules Modules are contains for multiple resources that are used to. A module consists of a collection of .tf and or .tf.json files kept together in a directory. Terraform modules is just used to the two types of file, .tf file and .tf.json file. So Terraform are used in two. .tf files are used these tools and .tf.json files are used in these tools in a server. So this is the Terraform modules. Structure of module. Module is a submodule. Module के अंदर submodules. Submodules is a three main module. Main.tf, variable.tf and output.tf. So three submodule. Module, submodule and three tf file. Main.tf file, variable.tf and output.tf. So contains main.tf. Main.tf contains the primary resources configuration. Contains the primary sources configuration as a main.tf. Variable.tf defines input variables to parameterize the module and finally the output.tf. Output.tf is a specified output value to export information about the resources. This is the output.tf. Okay. So this infrastructure as code is a module, submodule. The module is a three tf file, main.tf, variable.tf, and output.tf. Types of Terraform modules: root module, child module, and publish module. The types of Terraform module is a three module. Root module. The root module is the default module in every Terraform configuration containing resource is defined in .tf file within the main directory. And child modules. These modules can call other modules, allow reuse of resources, and simplify complex infrastructures by breaking them into smaller manageable components. So this is just child module. Publish module. Terraform can load modules from public or private registry. So allow you to use share module created by other. Publish module is a public or private registration. So root module is a tf.tf file. Child module is small manageable components, and publish module is a public or private registry. So these three types of Terraform modules. Variables. Variable in Terraform are essential for parameterizing configuration, enable flexibility and reusability. Variable declaration. Variable instant time body. Open description, ec2, instance type string, default dot t2.micro particular. This is a variable declaration. Variable type. Variable type such as string, number, boot, list, set, map, object, tuple, etc. This is a variable type. String, number, bool, list, set, map, object, and tuples. So this is a variable types. Outputs. Output value in Terraform work like return value in programming. So they make architecture into visible in the command line interface and share data based over other configuration. So user include child module, exposing specified data is parent module, displaying key value, Terraform apply, and sharing data by remote share state Terraform remote state. this command. So output instead IP address, value, AWS instance server private IP, and body kilo. So this is a declarative and output value. So this is a Terraform office. Terraform based CI/CD pipeline. Use Terraform to define and provisioning infrastructure within a continuous integration and continuous delivery pipeline to ensure consistent, repeatable, and auditable infrastructure deployments. So this is the CI/CD pipeline. Source code CI means validate and plan. CD is apply. Continuous integration and continuous delivery. Continuous integration validate and plan, and continuous delivery is apply. Apply the code. So infrastructure is a reserve. So source code, continuous integrate validate and plan, internal delivery is apply, and infrastructure as code. So store Terraform configuration is version control. Store Terraform configuration in version control is a Git. Set up CI. Git is a source code. Source code are used in Git, and set up CI, validate and plan, validate, format and plan Terraform code. Write a code is a Git, and Terraform code, validate, format and plan is a Terraform code. And set up a CD, continuous delivery, is automatically apply Terraform plans. Plans are used to CI/CD automatically. Integrate security checks for best practice area architecture. So this process of Terraform-based CI/CD pipeline. First, write a code gate, and second step CI, continuous integration, validate, format, and plan, and Terraform code. And next is just CD, apply, set CD, continuous delivery to automatically apply Terraform plans, and finally is integrate security check for the best practice of architecture is code. This process of Terraform with a CI/CD pipeline. Next is security in Terraform. Next topic is security in Terraform. Introduction to Terraform security. Challenge. Terraform manage infrastructure as code, but misconfiguration or store secret can lead to breach. Key risk. Hard-coded secret API key password in state file or code. Non-compliant architecture due to lack of utilities. Solution secret management security handles sensitive data. Policy enforcement ensure compliance by automated checks. This solution are this. Secret management in Terraform best practice. Use Terraform input variable be sensitive to leverage external tools such as HashiCorp, Vault, AWS Secret Manager, Azure Key Vault, and environment variable. Variables within the TF variable previous. So avoid storing secret in plain text state file. Example variable DB password type string sensitive equal to particular. So this is an example of secret management in Terraform. Policy enforcement. Policy enforcement. Why policy? Prevent risky deployment, public S3 bucket, and unstrict SSH key. The tools are HashiCorp, Sentinel, Policy Export, Open Policy Agent, OPA, which is Open Policy Agent plus Terraform. Rego-based checks. TF, plain check, OV, pre-deployment static analysis. Example, Sentinel policy man true or TF plan dot resource for AWS S3 bucket. This is a public grade. So why policy are you? And these tools are used. It's a policy information. Testing. Next topic is the testing infrastructure as code. Introduction to Terra test. TerraTest is a Go library and provide patterns and helper function of testing architecture. It has first-class support of Terraform, Packer, Docker, Kubernetes, AWS, GCP, Google Cloud Platform, and more. Purpose validate Terraform, Kubernetes, Packer, Docker, and other infrastructure as code deployments, and automate end-to-end tests for cloud infrastructure. So key feature is just support infrastructure. The test tools are use support AWS, GCP, Azure, etc. Integrate-based testing frameworks provides helper for SSH and AWTP request infrastructure. Jaco. So this is an introduction of test. Benefits and best practice. Benefits, reliability, automation, and multi-cloud. Best practice, isolate test, ephemeral environment, use timeout, flex for long deployments, combined with unit tests. Tap on validate. Next demo is infrastructure code security scanning and testing with TerraTest. AI assistant code generation. AI assistant code generation leverage artificial intelligence to automate and enhance code writing, improving speed and accuracy. So tab 9, an AI-powered code completion tool supporting over 80 languages, including Terraform. Benefits, accessibility, deployment with constant aware code suggestion, boost productivity for infrastructure as code with Terraform. AI assistant code generation, HashiCorp Bitcoin. Next is HashiCorp Bitcoin, a tool building, deploying, and releasing application across platform. Azure, Kubernetes, AWS, and ECS. Terraform defines base provisioning and architecture for application used in Bitcoin workflow. Workflow is a developers use tab 9 to generate Terraform code quickly. Why point you this configuration to deploy application consistently? So this is a workflow of AI assistance code generation. Next is anomaly detection in architecture metrics. Introduction to anomaly detection. Anomaly detection, these process identify unusual patterns in architecture metrics, CPU usage, memory, disk, input output network traffic. So that may indicate platform issue is failure. Role of Terraform in architecture is core tools used to define, provision, and manage infrastructure resources. Monitoring tools, Amazon CloudWatch, monitoring Terraform monitoring tools are Amazon CloudWatch collect and analyze infrastructure metrics using machine learning for anomaly detection to identify deviation from normal behavior. Integration, Terraform provisioning AWS resources and configuration CloudWatch alarm integrating and CloudWatch anomaly detection by AWS CloudFormation or other methods. So this is introduction to anomaly detection. Next topic is anomaly detection with Terraform. Terraform standard AWS provider lack direct support for CloudWatch formally anomaly detection, but it can be achieved through. This is a CloudFormation integration. This is the AWS CLI, command line interface. AWS CloudFormation integration use the AWS CloudWatch anomaly detector source in CloudFormation template within Terraform. This format is a template is a AWS CloudFormation integration. AWS CLI, AWS Command Line Interface or SDK workarounds. Execute AWS CLI command by Terraform to enable anomaly detection. So this anomaly detection with Terraform. AWS CloudFormation integration and AWS CLI or SDK workarounds. Source, post, prediction, and optimization using machine learning models. Machine learning or cloud infrastructure management. Terraform is an infrastructure as code tools that enable the defined provisioning and management of cloud resources in a declarative way. Machine learning models such as time series forecasting, ARMA, LSTM can analyze historical cloud usage data, predict future resources cost with high accuracy. So this is a machine learning cloud prediction management. Cost prediction and optimization, machine learning techniques and Terraform tools. Time series, machine learning technique, time series forecasting for accurate cost prediction and anomaly detection for identifying unexpected spending spikes. Terraform role is automate resource provisioning and scaling based on machine learning prediction and integrate with tools like InfraCost for force estimation during plan. Example, use machine learning to predict peak usage time and Terraform to scale resources accordingly, minimizing over provisioning cost. So this day for prediction and optimization. This is just summary is understand automation provisioning, improve infrastructure code, manage and applying the check errors, compliance and reliability, generate code with AI and automate resources using machine learning insight. This is the summary. Okay. So if there's a question, any question, please like and subscribe my YouTube channel. So any question, so please the command. So like and subscribe to my YouTube channel. Thank you. Next lecture, next topic is tomorrow. Okay. Thank you. Goodbye.